Hello and welcome guys. So in the last video we have seen that how to do a model selection based on our use case. So we explored Keras API. So we went to this keras.io and just go to this API docs, and in this API docs if you go in models API, then you will get here Keras application. Yeah, this one. So these are the list of available Keras models. Okay, so these are some pre-trained model which you can use for image classification task. Like here they have given that available models and usage examples for image classification. So they have also given the examples. So we have seen in the last video this list of all the models, and we have discussed in detail about all these things and how to select model. So everything we have discussed in the last video. So if you're new to this video, then please watch this playlist from beginning. So we decided to select this model, MobileNet V2 models, because it is small and we can train this model from scratch as we have very good amount of data set. So just go here, and inside this MobileNet V2 category, we decided to use this MobileNet V3 large model, which is the best model in this category. So we'll use this model. So just copy this code from here. Okay, so this is the code to use this MobileNet V3 large model. So why I am exploring this API, so that if you don't know anything, like if you are new and if you want to build your own project, then you can easily build your project by taking help from here. Okay, because you can't memorize each and every parameters and how to use these things. Okay, so that's why you can use this API and you can easily build your deep learning model. So just copy this function from here and just go to your VS Code. So what I will do, I will paste here. Okay, and I will give this to MobileNet. Okay, MobileNet. So this is our MobileNet model. So in this we have to do some changes, like here input shape I will give uh, my this image size, whatever image size I am using here. Okay, so I'm using here 224 cross 224. So first let's run this cell. Okay, so I'm using here my TensorFlow environment. So I'm running this, and I have to run this tooth cell also, and this is my training set. And after this I will create one more cell, and here I will define my input shape. Okay, so I will define my input shape. Input shape is equal to, and my input shape will be 224 cross 224 cross 3. Okay, so I don't have any constraint of size, as our model, this MobileNet model, is trained on 224 cross 224 size of images. So the same size I am putting here so that I can get good result. Okay, so this is my input shape, and this input shape variable I will pass in this parameter. Okay, alpha value I am putting the same, and these things I am also putting same. So we don't have to do any changes here. Class is also fine, and this name I'm removing because we don't need this. Okay, so I'm removing this name from here, and let's run this. So it's saying name Keras not defined, because here we are using TensorFlow. So if we want to use Keras, then we have to give here like this tf.keras. Okay, because we are using TensorFlow 2. Okay, now what we will do, we will define our architecture. So this is our model. So to define our model, I will use tf.keras.models dot sequential. I will use this thing. Okay, so this is my sequential model I have defined, and in this I will add some layers. Okay, so first layer will be our input layer. So to add our input layer, we will use here tf.keras.input I will use, and in input I have to pass shape. Shape is equal to, I will pass input shape, this one which we have defined here. So this is our input layer, and then after input layer I will add our MobileNet model. This model I will add. So I will write here model.add, and in this I will add this model, this layer. So in this we will get all the architecture of this MobileNet, followed by convolutional layer and max pooling layer. So everything will get appended. Okay, so the architecture of MobileNet I have already discussed in the last video. Okay, So we have added this MobileNet architecture. So I'm executing this. So we have successfully added our MobileNet model. Now we will add the output layer here. Okay, model dot add, and I will add here tf dot keras dot layers dot dense I will use, and inside this I will use units. Units is equal to 4 I will give, because we are solving here 4 class problem. And activation I will use as softmax activation function, because it's a multi-class problem, so we'll use softmax activation function. Okay, so we have added our output layer. So first we have added in our input layer, which will accept the data in the form of this 224 cross 224 cross 3. And then I have added my MobileNet architecture, and then I have added this my output layer. Okay, and after this I will define here metrics. Okay, so I am giving here metrics list, and in this I will define all the evaluation metrics which I will use to monitor the performance of my model. So first I am using this accuracy. So once we start our training, so it will compute after every epoch, it will compute the accuracy of the model, what is the training accuracy and what is the validation accuracy. And I also want to compute F1 score. Okay, so that I can see that what is the F1 score of training set and what is the F1 score of validation set. So to do that, you can use here tf.keras metrics you can use, and inside this you can use from metrics you have to use this F1 score. Okay, so if you use this thing, then it will compute accuracy and F1 score for training set and validation set while training the model. So it will be easy for you to monitor your model performance based on this two metrics measure. Okay, so I have defined my accuracy and F1 score, and now I will compile my model. So I will write here model dot compile, and inside this I have to pass my optimizer. So optimizer I will pass tf dot keras dot optimizer. I will use optimizers, and you can use directly here adam. Okay, you can use here adam optimizer, and you can write here learning rate is equal to 0.0001. I'm using small learning rate. Okay, I've tested it on this and I'm getting good results, that's why I'm using this. And loss I will use here categorical cross entropy underscore cross entropy. And metrics I will pass here this metrics list I will pass. Okay, so that it will compute accuracy and F1 score for this model while training. Okay, so this is all about this. So it's saying that at this time version 2.11 plus tf.keras.optimizer.adams run slowly on Mac M1 and M2. Okay, so please use legacy optimizer instead of this. Okay, so for me, like I'm using here Mac M2, so for me it's saying that you have to use here legacy, so it will improve your model training. So I'm using this, but if this warning is not shown in your case, then you don't do any changes here. Okay, so I'm doing the changes as it's mentioned here. So tf.keras.legacy I will use inside this before this adam call. So I will use here legacy. If this warning is not showing in your case, then please don't use this. Okay, now I will do here model.summary to see my model architecture. So if I do this, then I will get this thing. So it's saying that we have mainly two things here. First is this MobileNet v3 large, and second is this dense layer. Okay, so we have this MobileNet architecture, and then we have added this dense layer. Okay, this is just to tell model what type of input is expected. Okay, so that's it. So we have two things. So inside this MobileNet v3 large, we have a bunch of convolutional layer and max pooling layer. Okay, now we are ready to train our model. Okay, so to train our model, we can like first to record the history, I will write like this training history, and I will write here model.fit, and inside this I will pass x is equal to training set and validation data. Second thing is validation data. So in this I will pass validation set. Okay, this thing I will pass validation set. And epoch I'm using 15 right now. Okay, so 15 epoch I'm using because I have tested it on different epochs, and 15 epochs is sufficient to train this model. So that's why I'm using here 15. So if I execute this cell, then we will start training our model from scratch. Okay, it will use this MobileNet v3 large, all the architecture of MobileNet v3 large, followed by this dense layer. Okay, and it will train your model and give you a result. Suppose if you don't want to train this MobileNet architecture, you want to freeze the weight whatever Keras has provided, because it is a pre-trained model, so definitely it has some weight. It is trained on some images, and definitely you will get some weight. Okay, so if you want to use that weight, and if you want to train this only the last layer, that is if you want to perform only the transfer learning, so you have to freeze the weight of this MobileNet architecture. So how to perform transfer learning and how to train your this entire model from scratch. So I already said in the last video that we will discuss later when we are building this model. So right now it's time to discuss that. Okay, so here I will so if you want to freeze the weight of this thing, then this MobileNet you have. Okay, so you will write here this MobileNet, and you will say that dot trainable, you will use dot trainable. If you do this to false, then it will freeze the weight of your this MobileNet architecture, and and once you run this model.fit, then it will only update the weight of this dense layer, whatever layer you have attached, except this MobileNet. Okay, except this MobileNet, whatever layer you have attached in your model, it will update the parameters of that layers. It will not touch the parameter of this MobNet. Okay, it will not touch this MobileNet parameters, because here you updated this trainable to false. Okay, so it will freeze this thing. Okay, so you can write here like used to freeze weights of this pre-trained model. Okay, so if you do like this, then it will not update the parameter of your MobileNet architecture. It will only update this dense layer. Okay, it will only train the last layer. So this thing is useful when you have small training set. If you don't have this much number, like here we have 76,515 files, so we have very good amount of training set. Okay, so we can train this entire MobileNet architecture from scratch. We can train this MobileNet model also. We don't want to freeze the weight. Okay, because it can also affect your model accuracy. So if you have less training example, then definitely you can't train this big model. Okay, this big MobileNet architecture, and this followed by this dense layer. Okay, so it's a 21 MB model, so you can't train this big model. So at that point you have to freeze the weight, and so that you are saying that whatever feature is learned by this MobileNet architecture, use that ability of this MobileNet model, and add some 2-3 layers, and only train the last 2-3 layers. Don't touch the weights of this. Okay, so here as we are training this this type of images, so definitely this MobileNet model architecture is not able to understand these things. Okay, so that's why we are training this model from scratch. But now you know that how you can do transfer learning and how you can train this entire model from scratch. So if you want to do a transfer learning, I can write here like if you want to perform transfer learning, then you can then execute this cell. Okay, so if you want to perform transfer learning, then execute this cell, and if you don't want to perform transfer learning, then don't execute this cell. Okay, so right now we are not going to perform transfer learning, so I am commenting this. So I just want to show you that how you can do these things. Okay, and what is transfer learning and these things I have talked in the last video. So if you don't know, then you can go there and watch that video. Okay, so I will run this cell. Okay, from here, and now we are ready to train our model. So our training is started. So let's wait for some time. Okay, so we have successfully completed our training, and after spending 259 minutes 44.7 seconds, we got this result. Okay, so for me it takes more than 4 hours to complete this training. Okay, After 15 epochs, this is 0.1180 is the loss. This is a training loss, and training accuracy I am getting 0.97, which is 97.17%, and F1 score I am getting 0.95, good, and validation loss I am getting 0.17, okay, and validation accuracy I am getting 0.95. It's good. Like 0.97 is training accuracy and validation accuracy is 0.95, and validation F1 score I am getting 0.91, and training F1 score is 0.95, which is good. So we are getting accuracy of our model more than 90%. Okay, so now let's save this model before our kernel die. Okay, because if it get restarted, then we will lose all this variables, this training history and model. Okay, so before that we have to save this. So do here model dot save, and inside this we have to write dot slash, and I'm giving here trained eye disease model. Okay, dot h5 I'm giving. Okay, so it's giving me, so we have successfully saved this model in the form h5 file, but as here we have used this optimizer as inside this we have added this legacy, okay, before this addm, to improve this performance, because I am using here Mac. That's why he is saying that you are saving your model as hdf5 file via model.save. The file format is considered legacy. We recommend using instead native Keras format. Okay, so it's saying that you have used your optimizer as this legacy dot addm, this addm category from this legacy, so you have used this thing, so that's why you have to save your model in the h5 file format. So that's why I'm also saving this in Keras format. Okay, because it will optimize this file formatting as compared to this h5. So it's recommending me to save in h5 Keras format, so that's why I'm saving it in Keras also. Okay, so we have successfully saved our model in both format, this h5 and Keras format. If you're not getting that warning, then only use this h5 file format model, but I have saved in both format because I am getting that warning, so that's why I'm using this. Okay, this is completed, and any model is okay. You can do prediction using h5 also, you can do prediction in Keras also. Okay, but like for me I can use any of this. Okay, but I will if you're using Windows PC and here you are using tf.keras.optimizer.addm, then I will recommend you to use this h5 file format model. Okay, here I have used this legacy to optimize my training time, so that's why I have saved in this Keras also. Okay, next we have this training history. If I show you, so let's print this, so it's in this format. Okay, so to print the exact value we have to do here training history dot history, so it will give me the dictionary form of this. So I will save this history also, so that I doesn't lose any information. I have saved my model, so in future if I want to use this model, then directly I will load this model and I will use this model. Okay, and now we have to we have to save this variable information also, that is this information. So for that we are doing this thing. Okay, so I'm going to save history. So to save history, this time I'm going to save history in the pickle file. Okay, earlier we in my plant disease playlist and fruits and vegetable playlist, so there I have saved the history in JSON file format. Here I am going to save this in pickle file format. So today you will learn how to save that in pickle file format. So the same thing we have to do, training history. So here I will give capital T so that I can differentiate. Okay, training history dot pickle I will give. So pickle extension is this dot pkl, and I will define my mode. So this is the write mode, and as f I will do, so I am opening this file in write mode and I am using pickle, and pickle dot dump I will do, and inside this which variable I want to dump, so I will do training history dot history. Okay, this thing, this entire thing, training history dot history. Okay, so this entire thing I want to dump, and which thing and to where, so in this f. Okay, so this thing we have to use, but before that we have to see whether we have imported pickle or not. Okay, so we have not imported pickle, so we have to import first pickle. Okay, so here I will write import pickle. Okay, import pickle I am doing. So let's run this. Okay, so we have successfully saved our history in the pickle file format. If you go here, then you will get this. Okay, training history.pickle you are getting. So that's all for this video. We have successfully trained our model and we have successfully saved our history. Okay. Okay, so in this video, what we have done? Okay, so first we have loaded this MobileNet V3 large model. This is the best model in MobileNet categories. And here we have passed this input shape, which we have defined here, which is 224 cross 224, and this 3 is RGB format. And here we have defined sequential architecture, and inside this we have passed first the input layer, which will define what type of input is expected in this model. And then we have added this MobileNet architecture. So this is the MobileNet architecture which we have defined. So we are adding in our model, and then we have added one more layer, which is our output layer. Currently it's 4 because we have here 4 classes. Okay, in our training set we have this 4 classes, so that's why we have added this. And we are also defining this metrics list to monitor our model performance. So for monitoring, we are not only using accuracy, but we are also using F1 score, because F1 score is the best metrics to evaluate how robust our model is on different classes. Okay, so that's why we are using these two metrics. And here we are compiling our model. So we are passing this Adam optimizer and categorical cross entropy loss and this metrics list. And this is our model architecture which we are using here. So this is the total parameters, and this is the trainable and this is non-trainable parameters. And once we are doing this model.fit, so here we are getting the result on each epoch how our model is performing. So at first epoch, this is the accuracy, this is the training accuracy, and this is the validation accuracy we are getting. And after second epoch, we are getting 92, and this is what we are getting. So if you see here, validation F1 score is 82, 0.82, then 0.74, then 0.88, 0.99, 0.89. So it's increasing and decreasing, and after some time, like from I think from here from 11th epoch, it's getting more than 0.9. So it's around 0.9 to 0.91. So it gets saturated after this 11th epoch. Okay, so this is what we are getting here. Okay, so after that we have saved this model in H5 and Keras file format, and we have also saved the history to in future, so that we can do the visualization of the history, and we can see our model performance with respect to each epochs. Okay, so that's why we have done up to here. Okay, so in the next video we will further evaluate our model on test set data, because here if you see we have training set, test set and validation set. So monitoring and model development is completed using training set and validation set. So by seeing the validation loss and validation accuracy, we are saying that it is a good model, so we can use this model. Now further testing is required. So in the next video we will perform further model testing using this test set data. Okay, so that's all for this video. We will meet in next video. Thank you guys. Thanks a lot for watching this video.